with that formulas here. Find the maximum value of capital M by small m for which the block will land on the table. So as it slides, normal contact will act component, so that will make it to wedge to make it to accelerate towards right. So somehow I think if you can get the acceleration of the wedge, we can really focus on the things. So how to get acceleration of the wedge and the block, that too with respect to ground. If you know formulas, well and good, straight away. Now we'll do one thing. In the ground frame, shall we do this such problems? Because till now we did only with respect to what, like in the wedge frame. Let's try this problem in the ground frame. First we'll get acceleration, then we'll see what we can do it. This is theta m2. This m1. So acceleration, what are the forces? This will be n1 straight away, m1g, m2g, n2, and this is n1. So acceleration of this will be in the ground frame. How the acceleration of the block? a1x and a1y. We are doing totally in ground frame. Can we think like this, or we must do with respect to wedge frame only? I think you must really try, student, once. So methods, no, like see, one which is very easy, convenient. You can stick on to that in exam. Okay, what are the forces that are responsible for acceleration of the wedge? It will be n1 sine theta equal to m2 e2. Then along y-axis, m1g minus n1 cos theta equal to m1 a1y. Along x-axis, n1 sine theta equal to m1 a1x. One thing I'm very sure, a2 should be equal to m2 a2 should be equal to m1 a1x from the equation. One and three. Okay, what is the other help I should take here now? How many unknowns are there? N1, A2, A1X, A1Y. Relation between A2 and A1X is what I just obtained. Or four unknowns, better say A1X, A1Y, N1, and A2. I need one more equation. I'll come to this later on. So that will be easy for us to think what has to be done. Anybody? In the ground frame, I think we cannot solve. That's why usually all these problems in the textbook, they're shown with respect to wedge frame, the motion of the block. Is it like that?
Also, we can solve.
No external forces along x-axis. So acceleration normal to wedge is 0. That is what, no? Acceleration along common normal must be equal. Acceleration of the wedge, acceleration of this point should be equal to acceleration of this point along common normal. Acceleration of wedge and block along common normal must be equal. The reason for that, what is the reason? As N1 will be non-zero, because the block will be in contact with the inclined plane of the wedge. So acceleration along common normal is 0. This is a wedge constraint. I wanted to really focus on this, because you do get best questions based on this idea. Usually we know if a string comes forward, we write constraint equation as we are very good. But do think on this one. Acceleration along common normal must be 0 when the two surfaces are in contact. Must be equal. If both, these two can be at rest. If this is having acceleration, this should also have same acceleration. Okay, let me draw a common, there's a common tangent, there's a common normal. What are the accelerations we have? A1x, A1y, and this is A2. Okay, this is that common normal. Let's write the equation. A2 sine theta along common normal. A2 sine theta plus A1y cos theta minus A1x sine theta equal to 0. Agree this? So 4 equations, 4 unknown. Solving that, we'll get the acceleration. I think better substitute 1, 2, 3. We'll get expression for N1. After getting N1, then we'll get A2, A1y, A1x. Put books maximum, they avoided this discussion, I don't know. But the JEE Advanced, we do have numericals related to this idea, constraint equation. Wedge constraints is string or acceleration along common normal of contact surface must be 0 or must be equal, better say. Put 1, 2, 3, and 4. A2 will be N1 sine square theta by M2. A1y, M1g, N1 cos theta by M1 into cos theta. A1x, N1 sine square theta by M1. Solving this, I'll get N1. After solving N1, after getting N1, then substituting N1 in 1, 2, 3, we'll get all those accelerations. Anybody A2? Already, say you are solved by one method, go for some other alternative method. That's the best way of learning. I think if you refer our icon book, we do have this particular formula. It was derived G sine theta M2 plus M1. I suggest you better remember this. So many places this will play a vital role. This is a, so sorry, a naught is needed. No, we don't need this one. A naught is needed. A naught will be mg sine theta cos theta m plus m1 sine mg. Shall I take this value? There's a value of A2. Okay, but again, what we needed, we need A1x and A1y. After getting A1x and A1y, we should calculate acceleration of the block relative to the wedge. I think this problem has become lengthy by doing with respect to ground frame. Even you do in the wedge frame also, we have to work out. There's no other way. After this, what we should calculate? Acceleration along this. So A1y and A1x, if we know it, the resultant of that should be along the incline. So now we know A2. So what is the time taken? So for the wedge to come to this position, L by 2 of A2 T square I'll explain the what is overall the problem is this much here. Finally, and the block what happened will just land on the so it will take some time no for the wedge. So what is the acceleration of the wedge will be A2 and it'll be uniform accelerated motion. What is the length it should, how much of distance it should move? L by 2. So what is the equation now? L by 2 equal to A naught A2 no, we took A2 T square by 2. Able to understand the question? I'll minimize so that you can see complete. Yeah. So this is a time taken. This is T equal to 0. This is T. Time taken. In this interval of time, sort of the block has to cover a distance, how much it is, say small l. It will have some acceleration with respect to wedge. That AR we have to calculate. How to calculate AR? Now, what we needed? We needed acceleration of the block with respect to wedge is needed. Find the maximum value of M for which the block will land on the table. No? Oh, A2 equal to A1x. Huh? Okay. Yeah, fine. It is available. No, M2 A2 equal to M1 A1x. From that, we'll get A1x. Then component of acceleration with respect to ground, how much it should move? L by 2, no? It should be. We can do it here only. So in that interval, so this should be equal to L by 2 should be equal to A1x T2 square. Can we write it? The displacement of block along x-axis should be A1x equal to A2 will get it. I think we'll be giving wrong. But A1x is not equal to A2, no? Oh, it is here L by 2. Then in that case, M1 by M2 should be 1. Huh? Actually, the block should reach this one. So how the block will move somewhere here like this.
So when I solved, I got 1, sir.
This one, huh?
M by capital M is equal to 1.
Oh, why we should M1 by M2? What will be that? M2 by M1 or M1 by M2? This should reach here, no? Okay, fine. Yeah, it should have displacement L by 2.
X component we can find out from there. We'll get.
Sir, then we can't use this condition that it will just land at the edge because it should travel that vertical distance also.
That's what, no, we can't.
Because he gave theta, sir. If he wouldn't have given theta, then we can solve like this.
No, I don't think so. I should write this one. Huh?
Yes, sir.
I should not write this. That's what I feel from. So better to calculate acceleration of the block along the incline. Along the incline. So for that, I know A1x and A1y. I'll resolve the components. I'll get AR. Then from there, I'll let me write. This is better. So what is AR? Again, the AR will be A1x cos theta plus A1y sin theta. There's a method. If you can get A1x and A1y, then it will be, okay, we know A2, no? So from that, we'll get A1x. I think some N1 is needed. Huh? I'm not very sure. I'll take it out. Why to make a guess. So we'll do one thing. First, you get the N1. After getting N1, substitute here 1, 2, 3. So then you'll get A2, A1y, and A1x. Then calculate the time taken by the wedge, the edge of the wedge to come to this position.
Sir,
Okay.
we can't write S by 2 equal to ART square by 2 also. It will become the same thing as previous one, sir.
Same thing previous one. Huh?
First equation will change it to L by 2 is less than equal to A2 T square by 2. Then we'll write for vertical. L tan theta equal to A1y T square by 2. Then we'll calculate, sir.
No, I'll do one thing. I'll calculate the motion of the block related to wedge.
Because it doesn't confirm what is asking us. In any case, even if the block is falling down or landing on the table, it will cover the distance, sir.
Vertical
It
distance.
will
Huh?
become the same thing as what we are doing previously. We'll go for vertical distance because the block reaching the table depends on vertical distance. Then we'll go for horizontal distance.
I think we have to. Okay, this value of here I'll substitute here. S is not L, no? Okay, it has to be. Okay, this, sorry, small L it is. Huh? Now you look at this. YL by 2. L is equal to AR T square by 2. AR is what? I'll find out here. What is L? L, I think, okay, we know L in terms of small L. Cos theta. I think that's what I feel. Now we can do it. Huh? So now substitute these two, divide these two, L and that will get eliminated. So substituting A2 and AR, we'll get it. And AR is from this equation. M2 by M1, he has given answer. Answer is 3. Huh? Yeah, you have to verify it. Here, better to do like this. This will be easier method. I
Also
feel
will
like
get two. Now also will get one only, sir.
one only. Yeah, solving
Yes,
this
sir.
also.
This
Sir, we'll
thing
get
and
one.
what we wrote previously is the
Both are
same
same,
thing.
sir. Both are same.
Uh-huh. AR cos theta. Okay, we have to.
Tunina, sir.
M2 by M1 equal to 1.
Yes, sir.
Then what is the need of doing all this? Directly from center of mass we can tell, no? If this moves. Oh, okay. So delta XCM. Then M2 by M1 means what actually you're saying is like a. How it is possible?
Sir, angle is given, so it is not like sure that the block will land at the edge for the minimum value. So
Find the maximum value of M by M for which the block will land on the table is telling. Minimum value. Minimum value means.
yes, sir. If we are getting a1y and a1x such that for all a1x we are getting that it will lie on the table, something like that, sir. We have to constrain it by vertical displacement, not by horizontal displacement.
Horizontal displacement.
Because this thing and what we wrote previously are the same thing.
Okay, this I'll take it out then. To verify, this will be. Along y-axis, it will be L by sine theta. And y is equal to a1y t square by 2. Tan theta is equal to y by L. So y equal to L tan theta. A1y value we know it. Dividing these two, then substituting A2 and A1y. Now check it with this. For that, we should know N1. Anybody N1? If you know N1, we can do something. I think I'll update this answer. I'll solve it and I'll update it. Or else I'll continue this from tomorrow from here. Let me solve and I'll conclude it. But M2 by M1 is answer given. Let me see where we'll end up.
N1 is 2 M1 M2 G by 4 M2 minus 3
Oh, you
M1.
have brought it. 2
M1 M2 G.
M2G by
4 M2 minus 3 M1.
4 M2 plus
minus 3 M1.
minus 3 M1. Oh, theta again putting 60. I'll continue for tomorrow from these values only. Okay, meanwhile, if you want, you can try this. But this answer given M2 by M1, we'll see whether we'll reach answer or not. Okay, thank you.